Okay, this is part 2 of our rectangle approximation method video. And we're going to just redo the same problem we did in part 1, the car that was traveling with the increasing velocity. And we picked our data or took our data every 2 seconds. So we're going to do it as an LRAM and an RRAM again. Let's just go 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So I'm just recreating the same graph we had in part 1. Okay. This time I'm just going to label my curve with the velocity values. So this is our V of t, and this is our t. Time 4, times 6, times 8, and time 10. So 50, 48, 44, 38. So please just fill these in on your workbook also. 50, 48, 44, 38, 30, and 20. Okay. Now in our last example, we took this whole entire area, because remember we want the area under the curve here. Yep, I wanted that to be, there we go. We want the area under the curve. So this is the area that we want. Because if we can find this area, if we could find it exactly, then that would tell us exactly how many feet we have traveled over that 10-second time. And what we did in the last video is we took a left ram, which was from the left-hand side, and then we created a rectangle. And we could see pretty quickly and easily there that when we did the left-sided rectangle approximation method, we found an area that grossly underestimated the actual area. And then we tried a right-hand rectangle, which when we topped off our parallel side, we grossly overestimated the actual area. So what we're going to do this time is we're going to do another left and right hand method. I'm going to change colors here. Purple, that's pretty. And instead of doing one ginormous rectangle that takes up the whole area, since we have 1, 2, 3, 4, 5, 6 points of data, if we create rectangles using every 2 seconds instead of the entire interval from 0 to 10, we'll create for ourselves 5 rectangles. So I'll show you what I mean. Left-hand rectangle. Well, let's make a rectangle starting at the left, but that only goes for the first 2 seconds. So there's my rectangle. If I now top off to get my parallel side, then we're talking about that being our rectangle. If we now take a second rectangle from time 2 to time 4, with our left-hand side of 2 to 4 being the height of that rectangle, then we're going to top it off and we're going to come over here. I'm actually going to make 5 rectangles. Rectangle 1, 2, 3, 4, and 5 using 2-second intervals. But at each interval, so in this case from time 4 to time 6, I'm going to pick my left-hand side as the height. And so you can see, hopefully you can see, that even though I am still underestimating, like I did before, I have a lot less underestimated area. So 6 to 8 looks like that from the left, and 8 to 10 looks like this from the left. So I end up being much closer to the actual area. I've still got this extra. Let me go back to orange. I still have this extra, but it's a lot less extra than I had before. All right, so let's look at that calculation then. So this time, instead of one big width of 10 and one big height of 20, like I did before with the left RAM, I have 5 rectangles, each with a width of 2. So I have 2 times my height of 20. My second rectangle is 2 times the height at the left of 30. My third rectangle has a width of 2 and a height of 38. And hopefully you can see what's happening here. We're going to add together 5 rectangle areas with a height of 20, then 30, then 38, then 44, and our 1, 2, 3, 4 last rectangle will be the one that goes from 8 to 10, whose height is 48. So now if you go ahead and add those up, and by the way, let's notice, let me grab my calculator. Let's notice that each one of these rectangles has a height or a width of 2. That's a GCF. So what we're really calculating when we do this left RAM is the width of each rectangle, which is 2, and then we're adding all of the heights. So you can grab your calculator and do the same. You got 20 plus 30 plus 38 plus 44 plus 48, and then you're doubling that, which is 180. So we end up getting 360 feet. Now that's much better than our estimate last time. We had a 200 as our lower estimate last time. We had an average of 350. Now we have a lower estimate of 360. So what we're going to be doing here is closing the window on our estimate. Now, what does that look like as a right RAM? Well, that still looks like we're going to take 5 rectangles, rectangle 1, rectangle 2, rectangle 3, 4, and 5. Each of those 5 rectangles, just like before, have a width of 2. So 2 is going to be multiplying the rectangles whose height we find on the right-hand side. So let's think about that. From 0 to 2, the right-hand side is at time 2 instead of 0, which is the left-hand side. So let's pick our height on the right, and then we're going to top it off parallel to the left. And then here's my first rectangle. It's an overestimate, just like it was an overestimate before. But look at how much all of this area here was an overestimate before. We're only overestimating this little bit. We're taking off all of this extra overestimate. So hopefully you can think this through a little bit. If we're going to be doing all of our right-hand sides, then we're going to be taking the value at 2, at 4, at 6, at 8, and at 10, and look at all of that overestimating we're taking off. Each of these 5 rectangles has a width of 2, but this time we're adding the right-hand sides. So that 20 is not going to get added in. We're starting at 30, which is the right of the first interval. Then we have 38, which is the right of the second interval. Then we have 44, 48, and 50. 1, 2, 3, 4, 5 rectangles. So we're going to sum up those 5 rectangles. 30 plus 38 plus 44 plus 48 plus 50. That's 210. And when we multiply that by 2, we now have an upper estimate of 420 feet. That's less than our original overestimate of 500. So now instead of our window being 200 to 500, with an average in the middle of 350, we've closed the window on our estimate by doing more rectangles. Those widths are smaller because we have more rectangles, so our estimate is smaller. It's now between 360 and 420. So down here in this example, our LRAM gave us 360 feet, and we have an RRAM of 420 feet. So let's do a little bit better like we did in our first video, and let's find the average of those two. And let's see, 360 plus 420 divided by 2 gives us a 390 foot estimate. So we still don't know the exact amount of feet that we've traveled, but we can be sure that we're getting closer to the actual answer, which is going to be closer to 390. All right, so what we wanted to get out of this video is how to get a more accurate estimate. Well, it's going to be by taking more rectangles with smaller widths. Matter of fact, if we could figure out and do 20 rectangles or 50 rectangles or 100 rectangles, getting smaller and smaller, as those rectangle widths get smaller, just like it did here, the amount of, let's go back and remember what we did when we took one giant rectangle. The amount of our over or underestimate gets smaller because we're taking off all of this extra that we had when we had one big rectangle. So we're going to be working our way into seeing how we come up with the exact answer, and that's coming up in our next lesson.